All right, so on these, the first couple, I have a radical in front of my parentheses, and then I have a binomial inside. And so anytime you have a number on the outside of the parentheses, what do you do with it? You multiply, you distribute it, right? So we're going to start, and we're going to multiply 2 square roots of 6 times 8. And if you remember when we did this last week, we multiply the numbers that are in the same position. So numbers that are not under the radical get multiplied together, and numbers that are under the radical get multiplied together. So if I'm multiplying 2 square roots of 6 times 8, what does that 8 get multiplied, the 2 or the 6? I multiply it by the 2, right? Because the 2 is not under the radical, and neither is the 8. So when we do that, we get 16 square roots of 6. And then we're going to do the same thing. We're going to multiply that 2 square roots of 6, excuse me, times the square root of 1/2. And if you think about it like this, if I put these together, what's in front of the square root of 1/2? A 1. Okay, so we multiply the numbers out front. 2 times 1 is 2. And then when I do the square root of 6 times the square root of 1/2, I just need to multiply 6 times 1/2. And what is 1/2 of 6? 3. So that becomes the square root of 3. Because anytime we multiply radicals, we keep the radical, and then we multiply the numbers under it. And then what I would need to do next is to try to simplify to see if I can combine these two terms. Does the square root of 6 simplify at all? No, it does not have a perfect square in it. None of these numbers go into 6. What about the square root of 3? No. So can I combine those? No. So we would just leave our answer just like this. Sorry. Everybody okay with that one? All right, what I want you to do is go ahead and distribute that square root of 6 on number 2, and then we'll talk about what has to happen after that. So we should be distributing that square root of 6 to both of our terms inside the parentheses. And then we will see what has to happen after that. If I multiply the square root of 6 times the square root of 3, what does that give me? The square root of 18. And then if I multiply the square root of 6 times 2 square roots of 15, that's going to give me 2 square roots of 90. And then we have to check to see if we can simplify. First of all, is 18 a perfect square? No, but does it have a perfect square that divides into it? It does. So we're going to split that up into the square root of 9 times the square root of 2. That square root of 9 turns to 3. That 2 stays under the radical. And then what about 90? Is it a perfect square? No. What perfect square goes into it, though? Nine times 10? Yep. All right, keep that 2 in the front. We simplify that square root of 9 to 3. That 10 stays under the radical. So I get 2 times 3 gives me 6. Am I able to add those together now? No. Okay, so we would just leave our answer like that. So multiply, and then you just want to simplify if you can, and then if you can combine them, you want to do that. Sometimes you can, sometimes you can't. Wherever. Anybody have any questions on those two? Okay, take a minute and write down 3. So what you're doing is you're looking for this perfect square. All right, so I have 8 minus the square root of 2 times 6 plus the square root of 2. This would be just like if I had x plus 2 and x minus 3, and I was multiplying them. We're going to just distribute what you call FOIL. It's still just multiplying. We take that first term, that 8, and we multiply it by each term in the second parenthesis. So we'll start with 8 times 6, which gives me 48. And then if I multiply 8 times the square root of 2, do I actually multiply the 8 and the 2, or do I just leave it? Just leave it, right? 8 square roots of 2. And that is a positive. And then I do the same thing with that negative square root of 2 in the first parenthesis. It's going to get multiplied by the 6 to give me negative 6 square roots of 2. And then I multiply a negative square root of 2 times a positive square root of 2, which is going to give me a negative square root of 4. Once we distribute, then we're going to combine any like terms that we can, and then check our radicals to see if we can simplify. First of all, what's the one radical on here that you see that does completely simplify? Yes, I can combine those two. I got a positive 8 and a negative 6, which is going to give me a positive, what, 2? What else do you see can simplify? That 4. What does the square root of 4 turn to? 2. And then what can I combine? The 48 and that negative 2. What is 48 minus 2? 46. Now, the order of these isn't really that important. I usually tend to stick the radicals in the back of my binomial. So my number without a radical and then my radical. But if you were to switch that around and say 2 square roots of 2 plus 48, that would also be, not 48, 46, would also be the same thing. Can the square root of 2 simplify? No. All right. And so we would leave our answer just like that. So try 4 for me. All right, so again, we're going to distribute. We're going to start by multiplying 2 square roots of 3 times 4 square roots of 3, which is going to give me 8 square roots of 9, right? Numbers outside times numbers inside. Then when I multiply 2 square roots of 3 times 3 square roots of 2, it's a positive, so we put a plus. And that's going to give me 6 square roots of 6. Does everybody agree with that? Okay. Then we're going to multiply a negative square root of 2 times a positive 4 square roots of 3, which is going to give me a negative 4 square roots of 6. And then we're going to multiply a negative square root of 2 times a positive 3 square roots of 2, which is going to give me a negative 3 square roots of 4. Everybody okay with that part? All right. Now, because before I start combining like terms, do you see a couple of perfect squares on here? Yeah, so I'm going to go ahead and simplify those first. What is the square root of 9? 3. And 8 times 3 gives me 24. I'm just going to bring the others down for right now. And what else is a perfect square? That 4. So that's going to be 3 times 2. And what is 3 times 2? 6. Okay. And then once I get rid of the perfect squares, then I can start combining my like terms and then looking at the radicals to see if they can continue to simplify. So if I start with this 24 and that negative 6, what's 24 minus 6? 18. And then I have a positive 6 square roots of 6 and a negative 4 square roots of 6, which is going to give me a positive 2 square roots of 6. And then the last thing I just want to check is, can the square root of 6 simplify at all? No. So we're going to leave our answer just like that. Is everybody okay with that one? Okay. Try both of those. Binomials that are exactly the same, they're called conjugates. And what happens when we multiply conjugates, think about this. If we did, let's go back to what we know. If we did x plus 2 and x minus 2, and we were to multiply that out, what always happens to those middle terms if you're multiplying a pair of conjugates? They cancel, okay? Now, this one is a little bit different because it doesn't have radicals in it, but when we multiply this, what happens is when we have conjugates that involve radicals, our middle terms will cancel just like every other pair of conjugates. But what happens is when I do that, sorry, trying to talk and write at the same time is not good. What is the square root of 9? 3. When I do that, those middle terms cancel, and what do I not have anymore? I don't have any more radicals. So when you multiply a pair of conjugates involving radicals, that means two binomials that are exactly the same with the exception of one's a plus, one's a minus. You should end up with a whole number as an answer, no radicals involved. What is 4 minus 3? 1. And that's what my answer would be. And we're going to have to hold on to that because we're going to use this tomorrow when we deal with our fractions. But anytime you multiply a pair of conjugates, that means two binomials that are exactly the same with the exception of the signs, you should always end up with a whole number. So if we do the same thing for number 6, 2 square roots of 3 times 2 square roots of 3 is 4 square roots of 9. 2 square roots of 3 times a square root of 2 is going to be a positive 2 square roots of 6. A negative square root of 2 times a positive 2 square roots of 3 is going to be a negative 2 square roots of 6. And a negative square root of 2 times a positive square root of 2 is a negative square root of 4. And then I'm going to go through and simplify my perfect squares. What does the square root of 9 turn into? 3. I'm just going to keep everything for now for just a minute. And what does the square root of 4 turn into? 2. So that gives me 12. What's going to happen to those two? They cancel. And so I end up with 12 minus 2, which gives me 10. Again, no radical left because I multiply a pair of conjugates. It happens every single time. Anybody have any questions on those? All right, we just got a couple more. Let's see. So with these, I have in parentheses 2 plus the square root of 3, and on the outside of the parentheses is a square. Anytime you have a binomial squared, we've done this before, what do I tell you have to do first? Write it, how many times? Write it twice. And it does not change. We write it exactly the same in both parentheses. And then once you do that, you treat it just like every other problem. You distribute, you combine your like terms, and you simplify if you can. Okay? Again, just make sure you write it twice, exactly as it is in both parentheses. Don't change anything. And then distribute. So go ahead and finish both 7 and 8. We're going to write it twice, exactly as it is, and then distribute. And combine your like terms. Just like you did, okay. All right, we're going to distribute just like we have with all of the other problems. First terms multiplied together. Try this one more time. Then I do the outside terms. 2 times the square root of 3 is just 2 square roots of 3. Then the inside terms, the square root of 3 times 2 is 2 square roots of 3. And then the last two terms, the square root of 3 times the square root of 3 is the square root of 9. I'm going to simplify my perfect square first. What does the square root of 9 turn to? 3. And then I can combine my like terms. What's 4 plus 3? 7. And 2 square roots of 3 plus 2 square roots of 3 is going to give me 4 square roots of 3. Can I do anything else to simplify? And then 8 is exactly the same. We're going to write it twice exactly as it is. We don't change anything. And then we do the distributing. The square root of 7 times the square root of 7 is the square root of 49. That's going to give me a negative 2 square roots of 7. The inside terms is a negative 2 square roots of 7. And then the last two, negative 2 times negative 2 is a positive 4. What is the square root of 49? 7. And then I can combine my like terms. What's 7 plus 4? 11. And then negative 2 square roots of 7 and negative 2 square roots of 7 gives me a negative 4 square roots of 7. Anything else I can do? Nope.